Who's actually going to benefit from a 3 kilowatts automated welding head like the CQWY SUP25A, and who would be better off putting their budget toward a more conventional laser source? If you're on the fence because the price feels steep for a piece of equipment you'll only use a few times a year, you're not alone. Link is in the description if you want to check the product details on Amazon. In this video I'm walking through the practical side of adding a robot-mounted welding head to a small to mid-size production line, so you can decide if the SUP25A is a smart spend or a flashy add-in you'll regret. First off, let's talk about the kind of shop that actually needs this. I've been consulting with a handful of precision metal fabricators who run CNC laser cutting stations and occasionally need to perform spot welds on thin-walled aerospace brackets. For them, the biggest pain point is the downtime caused by moving parts from a laser cutter to a separate welding station, then realigning everything for the next operation. The SUP25A is marketed as a platform automated robot welding head, which basically means it can be bolted onto a robotic arm and sit right next to the laser source. If your workflow already includes a robot that does pick-and-place or laser engraving, swapping the end effector for this welding head can shave minutes or even hours off each batch. That's the core value proposition: consolidate 2 steps into one. Now, if you run a hobbyist garage where you fire up a 500W CO laser a few nights a week, the SUP25A is probably overkill. The unit's 3 kilowatts rating is built for industrial throughput, and the water-cooled Raycus or Max laser source it pairs with isn't something you'll find in a typical maker space. Trying to retrofit a homebrew coolant loop just to keep the head from overheating will add complexity and cost that quickly outweighs any speed gains. In short, if you're not already investing in high-power laser hardware, you'll likely skip this one. Let's dig into the practical strengths that matter once the head is on the line. The first thing most users notice is the galvanometer motor that drives the X and Y lenses. In a real-world setting, that translates to microsecond adjustments when you're tracking a moving part on a robot. I saw a case where a manufacturer was welding a series of tiny battery housing tabs on a moving belt. With the galvanometer, the welding point stayed locked even as the belt jittered at 0.2 millimeters per second, delivering a consistent bead that passed their quality inspection without rework. That level of precision is hard to achieve with a standard servo-driven head, especially when you need to keep the weld spot under 0.1 millimeters of deviation. Another tangible benefit is the sealed internal structure. Many laser welding heads I've worked with have exposed optics that collect dust, oil mist, or coolant spray over time, forcing frequent cleaning cycles. The SUP25A's fully sealed housing means you can run it in a semi-dirty environment, say a sheet metal shop where grinding chips are airborne without worrying about the lens fogging up after a few hours. The sealed design also protects the focus lens from water splashes, which is a real concern when you're using a water-cooled laser source right next to the welding head. The lightweight, compact form factor also isn't just a marketing line. When you mount a heavy head on a 6-axis robot, the additional inertia can slow down the robot's acceleration and increase wear on the joints. The SUP25A's reduced mass means you can keep your robot's motion profile essentially unchanged, preserving cycle times. One small CNC shop reported that after swapping a bulkier welding module for the SUP25A, their robot's average cycle time dropped by 12% because the controller didn't have to compensate for extra load. That's a real productivity win. On the flip side, there are a few trade-offs you need to be aware of before you pull the trigger. The first is the dependency on the QBH interface. The head only talks to controllers that support that protocol, which means if you're using a generic robot controller or an older PLC, you'll need an additional conversion box or a firmware update. That adds a hidden cost and some integration headaches. I saw a user spend a full day troubleshooting communication errors because the robot's firmware didn't expose the required QBH commands, and they eventually had to purchase a separate gateway module. Secondly, the fast welding speed is only an advantage if you have the right downstream process. The SUP25A can deposit a high-energy weld in milliseconds, but that also means the surrounding material must be able to dissipate heat quickly to avoid warping. In a setup where you're welding thin stainless steel sheets, you may still need a pause between welds or a cooling station, which negates some of the speed gains. It's a nuance that's easy to overlook when you focus purely on the headline 3000W number. Another practical weakness is the water cooling requirement for the paired laser source. While water cooling is common in high-power laser systems, it adds plumbing, a reservoir, and